Okay, so first I want to start off by telling how I'm doing after surgery. Because I had my testicles removed Thursday a week. Well, okay, it was Thursday the 17th of September. I'll just go by the date. I'm terrible with weeks. Anyway, the point is I had surgery, and so I've had more time at home than I usually do because I can't go back to work yet. I'm not recovered enough for that. So, although I am sad about the fact that I'm not going to make as much money with my next paycheck, I have been spending my time doing a lot of computer programming. There's a lot of stuff I could do, in fact, video games I'd like to play. However, I felt more like working some more on my rolling checkerboard program. And so I want to show you some changes to what I did with it. And so I'm going to switch to recording my screen. Let's see. Okay, so I learned to do something super cool. So I'm going to go to my folder where I have, let's see, that folder, there's a specific folder. Okay, I know how to navigate to it. So first I go to my MSys installation here, and then I go to Home, Chastity. I didn't get it ready beforehand. I didn't think it would take this long. Okay, so this is the, first I'll show you, okay, I'll just go straight to the checker roll thing. So here I have a lot more files in here than I did previously. But I'm going to show you something I learned to do today that is probably going to speed up my programming so much it's hard to imagine the importance of this. Okay, so I'm going to open up my source file. This is the same source file I showed you before, with some changes. There's a lot of new stuff. The variables are the same. There's also a new header with another function. I might show you that, but it's not really important because the code in that is not really used currently. In fact, I'll just comment that out. So, what I used to have to do is I used to have to open a terminal and then copy and paste my commands, or just simply run batch commands that I had already prepared from a terminal. And so I used to have to switch windows. But I found something super cool. Now I want you to watch what I'm about to do. I am going to press F9, and as soon as I press F9, here comes up the terminal. It compiles and runs my code. So now my SDL Infinity Checkerboard is already here. So we have the 4 basic directions, which is cool, and that was the same as last time, but I want to show you something else. In fact, I'm just going to move this window more towards the center of the screen. So now I'm going to show you I can do diagonals as well. I can do diagonal directions. I basically just copy and pasted the code from my up, down, left, to right. So for example, the code for going up and the code for going right, I simply copied and pasted the code from those two switch case statements and combined it into one more. And so I'm going to show you how this works from a code perspective, but there's one more thing I want to show you first. I can change the size of the squares. Now, is that not the coolest thing or what? I can change the size of the squares. I can make them bigger or smaller, and then I can still scroll through them the same way I always could. So, as you see, I've made immense progress on my checkerboard program. What I'm able to do with it now is just incredible. So yeah, I am just doing the most amazing things. So I have a checkerboard that never ends, can be infinitely navigated, can be resized, which I consider this like zooming in and out. Like imagine this is a real checkerboard with an actual size, but you're zooming in and out from a distance. That's kind of what I'm going for here. Really, I'm just changing the size of the squares. So yeah, and I'm going to show you how this works. Now, first of all, I want to show you how in the world did I run this program suddenly without switching to a window and typing commands and all that. Well, here's the trick. Run. You see this? You can set certain shortcuts here. For example, if you can type pretty much anything in here. But here's what I actually did. I went here and I modified some things. Okay, so I created this make.command. Now when you look at this, the name of it is make.command, and the shortcut key that I selected was F9. And the reason for that is that was the first function key that was not already in use by the program for something else. Everything else before that did. In fact, F5 causes just the run dialog where you type in a command to go. But that's F5. But F9 is the shortcut that I made. So at any time I make a change to my source code, and then I just press F9, and then it compiles and runs it. It's absolutely amazing. Now, how does it know what commands to run? Well, that's where it gets very interesting. So I'm going to show you in the same folder as the source file I'm in here. I have make.command. Now this is the same as a batch file. I found out whether you have it with an extension BAT or CMD, either way, the Windows operating system will, when you double click it or you run otherwise, it will then run the commands in here. So what it does is first it sets the path to my compiler and the path to the SDL binary, and then it runs my huge compiling command using the name of my source file and all the compiling and link options, and then it runs it finally. So the beauty of this is any batch script that I can write, I can have Notepad++ run. Now there is a downside. Of course, I have to customize this based on the name of a specific source file. So this only works if a file with this exact name here is open or it doesn't have to be open in Notepad, but it has to be in the current directory that I'm operating in, basically. So if I was doing this with a different source file, I would have to set up a whole different command, and I can only have one shortcut key per file. So, but since this is what I was working on, I set my shortcut key for that. So now I can modify my source code, and I don't have to switch windows and open a separate terminal. So I'm going to show you there's some new things here. I'm going to show you I have rect less and rect more. Now these are functions for making the squares bigger or smaller. So for example, when the rect less function is called, first it halves the size of the squares, and then it has some error checking to make sure it doesn't become 0, because if the rect size becomes 0, my program starts going in an infinite loop and it crashes. So this was very important that I had to add. And then it sets the target surface to surface 1, because we're going to draw the checkerboard to surface 1. And then it has to reset the variables. It has to reset the selection rectangle of the view area that we're copying to the screen. All of this has to be completely reset. And these variables that you saw in my previous video that control everything, because all of that is defined here. Ordinarily, all of that code is defined here. But simply, every time we want to make the squares bigger or smaller, I have to do all of that. It has to redraw the whole thing. It has to reset all the math right. So there's a lot that goes into all that. But of course, because I already had the code and I knew how I set up the first time, I simply copied and pasted a whole bunch of code and made these functions so that I call these functions in specific conditions. Now, for the new keys I added, okay, so I added some things. So these are the ones that do the diagonals. Well, actually, first I'll show you minus is what calls rect less, and plus is what calls rect more. It's the numpad keys. So the numeric keypad keys and how there's a plus and minus key near them, those are the keys I press to call those functions. We're simply setting up our switch case to do this stuff. And also the diagonals now. So for 1, 3, 7, and 9, they represent specific diagonal directions on the keypad based on the way they're laid out on my specific computer. On yours they might be different. But if you press those on a number keypad, then it will do this code, and all of this code in these was actually just copied and pasted from various parts of up, down, left, and right here. And there's something else. Notice, for example, that we have case statements for certain keys, but that these don't have any code between them and the next case statement. That's because of what is called the switch case fall through. I read about this. So if you have a certain case that you want it to switch to when a variable is a certain thing in a switch statement, if you don't have a break statement, it will simply execute the next case. So the idea is that I'm creating more than one key that can be pressed to have the program do the exact same thing. So 2 is down, 4 is left, up is 8, and 6 is right. So I simply created alternate keystrokes so I can do the whole thing with the numpad. If you have a computer without a number pad on your keyboard, it might not work. I'm not sure about that entirely. In fact, actually, I'm going to check something. I'm going to run this again. Now, what happens now when I'm just pressing the number keys that are above the letters on my other part, it doesn't work. So I have to use the keypad here. Very interesting. Oh, this is cool. When I set the num lock on, then it does this. It slows it down. I'm not sure why that is. That's weird, but if I turn it off, then it goes back to normal. That's a little bit strange. I'm not entirely sure why the hardware works the way it does. But, you know, being able to make the squares move in any direction I like is super cool. So here I have the SDL Infinity Checkerboard. So I've created a rather unique invention that probably nobody else ever has, but it works. Also, I will show you a function that I worked on in extra.h. Actually, I need to show you this function and how it works. Okay, so in order to do that, you see that my program didn't actually use it, but if I uncomment this extra.h header, I'm going to show you something. Now, I changed some things in my code. It's always surface 1 instead of surface 2 now that is what is actually drawn to the screen, which is surface 0 is a synonym for the screen. So whatever is drawn to surface 1 is what will be will show up as we're scrolling. So here's what I'm going to do. I'm going to replace checker with Gingham. Now, that's the name of this function in extra.h. So this is a Gingham drawing function, and it fills the screen with something else. I'm going to show you exactly what it does. Oh, I don't need to switch windows. I forgot. Okay, F9. This will speed up my videos that I record. See this? Now it's the Gingham pattern. This is another square-based pattern, And it was fairly easy to make, really. I already had this existing source code, really. I had to modify a few things to get it to work with my specific program, but it does work. So I have Gingham pattern instead of checkerboard. But I will show you something. As soon as I press plus or minus, then it replaces it with a checkerboard again. And the reason for that is that when I modified the code just now, I had it set to draw the Gingham background into the image at the start, but nowhere else in the program does that happen. So basically, it's going to call the checkerboard function if I call rect less or rect more by pressing minus or plus. So it simply resets the program to be the way it worked before I replaced it with Gingham. So anyway, as you see, it works great. I have a lot of code and I'm very excited. I worked for so many hours today on making this code work the way I want it to. And technically Surface 2 is not really used in this one. Before it was Surface 1 that wasn't used, now it's Surface 2. But I haven't removed the code for Surface 2 because I still think there's going to come a time in the future where I use Surface 2. Now keep in mind that the actual running of the program is not actually slowed down by the fact that Surface 2 is present in the code, because nowhere during the game loop does Surface 2 appear anywhere except in this comment, which obviously is inactive. So I'm just going to show you one more time how it works in action, and we're just going to press F9 and it just does all that great stuff. So now you've been able to see my source code, and yeah, it's cool. You see my source code, you see how it works, you see what SDL is capable of. It's capable of so much more. In fact, I suggest you just look at the Steam games. If you bought any games on Steam, just look at the DLL files in their folders where they're downloaded, and you'll see a lot of SDL2.dll files in a lot of the games. That's because almost all of them use that. And even those that don't have a DLL file in them, they use the Steam. Steam actually provides the DLL file as part of their platform. So when users have games through Steam, it's not necessary for the developer to include that file in every game. But SDL is linked against either way. So it's really cool what SDL is capable of. So far, I'm very impressed. I was doing impressive things with Allegro, but SDL, I started using SDL more than Allegro just because I could not figure out how to statically compile and link Allegro. But also, I think SDL, being a small library, might be easier for me to fully learn than Allegro, which has so much more content. And SFML is nice, but don't even get me started on that one because it's all C++ based and it confuses me to no end because I'm a C programmer, not a C++ programmer. You know, I can do C++ and I obviously did it. I wrote a checkerboard program in SFML, but it doesn't do all the fancy things that my SDL program does that you're seeing here. So basically that's it. I hope somebody enjoys this. Yeah, I've done so much cool programming. I've just done so many amazing things. So let's see. Okay, that's the end of that. And I highly doubt many people are still watching the video at this point, but now that I'm done showing you the programming stuff, I wanna talk about some things related to just my health and stuff. Okay, so I'm feeling great after the surgery. I'm still in pain when I walk long distances. Cause yeah, it still hasn't healed down there, and I forget to use my ointment. But other than that, I'm feeling good. In fact, I've just been watching out for certain things because now you have to understand that an orchiectomy, removal of the testicles, is very, very similar to a hysterectomy. My mom had a complete hysterectomy when she had cancer. So she had the uterus and ovaries, everything removed. So removing the ovaries removes the source of female hormones that women have, but removing the testicles takes away the male hormones. Now, of course, we all have the so-called male and female hormones in our bodies, but one thing that happened to my mom after she had her ovaries removed is her skin dried up a little bit. However, of course, you know, she uses all kinds of moisturizing stuff, and she's doing great with that. But I've just been watching for things now, and so far I haven't had my skin dry out, because the oils of your skin, as well as acne caused by too much oil and stuff, is caused by hormones. That's why people start having acne in puberty. But I actually still have my oily skin. Like, I've always had really oily skin, and that hasn't changed, at least not yet. I'm kind of hoping it doesn't change. I want it to just be oily enough to be moisturized, but what I have noticed is that my skin feels a little bit cleaner and clearer, and that is one of the things that I read, is that you have like less acne when you have less testosterone. So that's another thing. So so far I'm feeling strong, and my skin has slightly less oil, but still quite a lot, because I always had really oily skin. So I feel like I'm having a little bit less acne, just cleaner, clearer skin in general. So my skin actually feels a lot better now than it did before my castration. So that's just a little interesting fact I wanted to share, since you're already here watching my programming video. So I'm feeling good, but I have been working on my computer programming all day, mostly researching things, going through the SDL library, and then learning all kinds of neat tricks and experimenting with software, which is precisely how I learned how I can just set shortcuts to run commands within Notepad++. So basically, I can have Notepad++ be my integrated development environment, because the only real thing that I use other IDEs for was editing code and then pressing a key to just build and run the code. But now I have that with Notepad++. Now, I'm also interested in using other text editors as well. Now, I do have a question, one question before I exit this video. Now, to anybody who's a user of VI or Vim, because I've used Vim, I'm not good at it. I don't usually write my code in Vim, but in case I become good at Vim someday, it's something I want to know, and you Vim users who program in Vim probably know the answer to this one. Does Vim have a way to do the same thing as what I just did in Notepad++? Is there a way that you can customize a shortcut key that automatically runs a command? Because if so, that would be cool. Like, I could use if I could use Vim and configure it to press F9 and then have it run a command in the shell so that it runs that program, and then when it's done, it goes back to whatever file I had in the Vim text editor. If there's a way to do that, will someone please let me know? I've tried to read a little bit of Vim documentation, but it's a big read, and I've already read a lot today. So if anybody knows the answer, could you just point me to somewhere that mentions how to do that? Because I might want to try that as well, just for fun, even though I don't really use Vim regularly. Anyway, that's all I have for now. Hope you've enjoyed my amazing Infinity Checkerboard.